We have seen how the roots are related to areas and how they are in some way related to powers. So the question is, could we represent roots as exponents? Let's see. Okay, to understand how we can represent roots as rational exponents, what you need to think is how to determine the square root of a number like 25. Or how to determine the cubic root of a number like 27. Okay? So if you remember the last video about roots, we understood that having the square root is just finding a number whose square that you need to get to the second power in order to find out the radical, the term that is inside the root. And the number here is going to be 5 squared. Okay? 25 could be written as 5 squared. So as you could see, the answer here will be 5. Or, when it's a cubic root, the idea is to find out what is the number that I need to raise to the third power to have the radical, in this case 27. So we know that the answer is 3, but it's the same as rewriting 27 as 3 to the third power. But if you think of how you can represent this expression as an exponent, you can think that these 2 could be divided by another 2 to have 1, okay, to have the 5 to the first power, or that this expression 3 cubic root of 3, I forgot to put the cubic root of 3 could be rewritten as 3 over 3, so you will have 3, okay? And maybe you will think something like, yeah, but I can use other strategies. Maybe I can 2 minus 1 or 2 minus 3 or 3 minus 2 and this type of things to have a third to the first power, 3 to the first power, or 5 to the first power. Yes, but look at that, in both cases I'm using the root. I'm using the index of the root. Look at that, the index of the root here is 3. Remember that when you don't write anything, you're using 2, and we're using the index of the root here. Okay? Now I want to show you how to do it with another example. For example, let's do it with a number that we know, 81. You know that the square root of 81 is 9 because 9 to the second power is 81. But what happens if I get the prime factorization of 81? If I get the prime factorization of 81, I'm gonna get 3 to the 4th power. So that will be kind of writing 3 to the 4th power. And look at what I'm going to do. I'm going to use the rational exponent that I used in the other exercises to see if it works. You know, that's the idea that we're going to do. We're going to see if it works, our rational exponent of that we have seen. So it would be 2, so it should be 3, 4 over 2. 4 divided 2 is going to be 2, so 3 to the second power is 9. Yes, exactly. So look at what we have done is that we just only convert the root, any root, into a rational exponent, in which the denominator is going to be the index of the root. So for example, if in general, let's say if somebody tells you, hey, I need to know how to calculate 64 to the 1/2, so you can know that 1/2 is the square root of 64, 8. Okay? And this is how you can work using the rational exponent. I hope that this video was clear for you, that you understand the meaning of the rational exponent. This is the basic idea, and this is how you can convert it to apply simplifications in the future. See you in the next video. Have a nice day.